Hello GMATers, my name is Gene Suhir and I'm going to be leading you through today's event. If you came for GMAT Advanced Workshop about achieving a score of 700 or above, you've come to the right place. You'll see below my head at the bottom of the lower left-hand corner what we have on the agenda for today. We'll talk about the importance of being a top scorer, achieving a 700 or above, an introduction to some high difficulty problems that high scorers encounter on the GMAT, and some best practices for achieving one of those top scores before we look at some of Kaplan's prep options at the end today and show you some promo codes for savings on those prep options. Now, today's event is called Achieving a 700 or Above. Now, it used to be that getting that first digit to be a 7, just a 700, would pretty much make people a shoo-in for some of those top programs. But scores have crept up a little bit in recent years, so even though 700 is a nice round number, really now Kaplan has found that it's a 718 or above that makes people more prime candidates for some of those top 10 programs. Even as you'll see a little bit later, that is slightly above the average for the top 10 programs that makes people really strong candidates for them. Now, of course, you can't score exactly a 718 on the GMAT. Scores are in increments of 10. You can get a 700, 710, 720, etc. But 718 is what we found is the median for those top schools. So on our agenda today, the importance of a 700 plus, so you know what to expect, especially if you're planning on being a top scorer. We'll introduce you to some high difficulty problems, those 700 level problems and above, so you can see where you stand and how you feel about those kind of problems. And you'll learn what makes some of those difficult problems difficult. And then we'll look at some best practices for scoring above a 700, show you some prep options, and give you some promo codes for those ongoing prep options. Now, why is the GMAT so important? You know, Kaplan has these seminars periodically where we invite admissions officers from various business schools, and we ask them what is the most important factor in the process when you look at students applying. And we find that that you'll see at the bottom here, 42% of admissions officers, higher proportion, say that the GMAT is the most important factor in the business school admissions process than anything else. Now, I know this might seem a little bit unfair that this test that'll take, 4 hours of your life, is going to impact your admissions more than your undergraduate GPA, where you worked for years, or work experience. But it kind of has to be that way because competition has become pretty fierce in recent years. That's why scores have crept up. So business schools need a common measuring stick by which to evaluate students. Now, there's a few other things, though. This quote is certainly important, that the GMAT's the most important factor in the business school admissions process. But maybe equally importantly, it's probably the one that you can still do the most about. If you are watching this presentation right now, you're probably either done with undergraduate or pretty close to it, so your GPA isn't going to change a great deal. As far as work experience goes, they like to see a few years of work experience. Well, you can prepare well for the GMAT in well under a couple of years. Now, some of those top 10 business schools, some pretty high scores. When I started teaching GMAT, which wasn't that long ago, it was about 7 years ago, out of the top 10 schools, a few of them had average scores of 700 or above. Now notice in those top 10, all of them do. For those top 10 business schools, the average GMAT score is 718. That's why we saw the number before, 718. And the average acceptance rate is 15%. So for every point, or I guess I should say 10 points, because it's in increments of 10, that you go above the average GMAT score for your target school, it makes you that much stronger of a candidate for their programs. It makes you stand out in a pretty competitive set. Because remember, the people applying to business schools come from a variety of backgrounds: analysts, consultants, some engineers. It's especially because of those engineers that the math scores have been creeping up a lot. Engineers deal with a lot of the math that, well, the rest of us don't deal with on an everyday basis. So if you are getting a 700 or above, it puts you in a pretty exclusive club among those that are applying for business school. Now, if you haven't taken a practice test before and you want to know what the GMAT covers, there was a recent change. Well, I guess not that recent. It was back in June of 2012. The addition of the integrated reasoning section. We'll look at the other sections too that will be on the actual GMAT. The integrated reasoning section that was added back in June of 2012 has 12 multiple choice questions, and I should also say they are multi-part questions too. So you might have 1A, 1B, 1C, and 1D. Total of 30 minutes. It's really about your ability to read charts, graphs, tables. That's why you see the question types there of graphics interpretation, two-part analysis, multi-source reasoning, and table analysis. Now, integrated reasoning is a totally separate score from the 200 to 800 that you get on quant and verbal. But that's the second section of the GMAT, and that's the one that's changed. The first section is still the analytical writing assessment, also known as the essay section. One essay to do in 30 minutes where you analyze an argument, break it into its pieces, and identify its flaws and suggest ways to strengthen them. That's also a totally separate score from 0 to 6 in increments of 0.5. So you have a half-hour essay before your half-hour integrated reasoning section. After that, there's an 8-minute break, and then you have the quantitative section. The sections will always be in this order. The quantitative section, also known as math, will have 37 questions to do in 75 minutes. And that will be a mix of problem solving and data sufficiency. And those are all mixed up within the 37 questions. It's not as though you have all the problem solving and then all the data sufficiency afterwards. Then an 8-minute break, and you have the verbal section. Always 41 questions to do in 75 minutes, and there is a mix of reading comp, sentence correction, and critical reasoning. The 200 to 800 score, that's the most important one. Usually when people say, how did you do on the GMAT? That's the score they're interested in, the 200 to 800. That comes from these last two sections, the quantitative and the verbal. Completely separately is the integrated reasoning section that goes from 1 to 8. And completely separately is the analytical writing assessment, also known as the essay, that goes from 0 to 6 in increments of 0.5. So by the time all is said and done and you're done taking the GMAT, you have 3 separate scores, and none of them has any impact whatsoever on the others. You know, as soon as you're done taking the GMAT, you're 200 to 800 from quant and verbal. But for integrated reasoning and the essay, those scores you get back in a couple of weeks. Somebody has to actually read your essay. Now, if you haven't taken a computer adaptive test before, it's a bit of a different animal, a different dynamic than any test you may have taken in the past. It's those last two sections, the quant and verbal sections, that are computer adaptive. Well, what that means is this. The test adapts to your level of difficulty. So with each of those last two sections, quant and verbal, it starts out with a medium difficulty question, roughly a 500 difficulty question. Every time you get a question right, your score goes up and the next question gets harder. Every time you get a question wrong, your score goes down and the next question gets easier. The computer is trying to find the level where you're getting every other question right. Or I guess if you're a pessimist, that's every other question wrong. So what you want to do is you want to be the person that pumps their score up early, for reasons we'll talk more about in a moment. And after that, if you, let's say after the first 10 questions, if you're up over a 700, if after that it goes wrong, right, wrong, right, wrong, right through the end of the section, you'd end with a 700. Now, I mentioned specifically the pumping your score up early. The implications of that are vital. The early questions will impact your score more than the later questions do. You even see here from this illustration that those arrows are a little longer in those early questions. The reason here is this. Suppose you get question number 1 right. The computer sees it as, wow, you got 100% of what I've thrown at you right. I'm going to pump your score way up and make the next question much harder. The computer's entire decision about what to do with you is based on that one question. By the time you get to question, let's say 20, if you get question number 20 correct, well, the computer now has a lot more information to work with. It will only impact 1/20th of the computer's decision of what to do with you. Now, sometimes people ask, so Gene, does that mean I have to get the first 10 questions right, the first 5 questions? There isn't a magic number, just early. Question 1 is more important than question 2. Question 2 is more important than question 3, and so on. So the implications of that mean that you have to make some pretty important timing decisions along the way, because there's a pretty significant penalty for leaving stuff blank at the end. You can take a perfectly good score and make it plummet if you leave things unanswered at the end. So somewhere along the line, you'll probably have to do some strategic guessing. The fact is, perfectionists do not do well on the GMAT. And I mention this especially for high scorers that oftentimes feel like they have to be perfectionists. If there's a question that comes up, and on the quant section it should be roughly 2 minutes a problem, some might be a little more or a little bit less. But if a question comes up and you give it 6 minutes, 7 minutes, 8 minutes, even if you get it right, it becomes a Pyrrhic victory. It's a victory at too great a cost. Because now down the road, there may be 4 or 5 questions you could have gotten right in that amount of time, but now you just won't have time to get to them. The psychology of it here is important because it's not like in college or high school where you could kind of play that how am I doing game. If you want to be a top scorer, you're going to see some pretty hard questions. And I know if this was a college or a high school exam, most students, they feel some hard questions. They think, oh no, I'm doing poorly. That goes out the window for a computer adaptive test. Kaplan has done studies on this. Had people take tests and afterwards, before showing them the score, asked them, how do you think you did? And people with 700s were more worried, were more pessimistic than those with 400s because they were seeing harder questions. So I hope for your sake, when you go and take the GMAT, you see some hard questions thrown at you. And I don't say that because I'm some kind of a jerk and I want you to suffer. That's not why I say that. I say that because if you see some of those hard questions, it means you've pumped your score up and it means you're doing very well. And that's where the GMAT can be much more forgiving for getting some stuff wrong, climbing up that mountain and then just trying to stay there. Because if you dig yourself a hole early on, it's a lot harder to climb out of that hole. So practice is really important to get used to that dynamic. That's why Kaplan gives our students 9 full-length computer adaptive tests, because your success on the GMAT means striking this balance between I have to get stuff right, especially early, but I also have to leave enough time to get through to the end of the section. Otherwise, there's a big penalty if you don't finish the section. And you always want to put something down for every problem. Leaving things unanswered at the end, it's one of the worst things that you can do on a computer adaptive test like the GMAT. Well, let's introduce you then, now that we've talked about the format of the test and the importance of a 700, let's introduce you to some 700 level questions, especially when it comes to math. Some students feel like, oh, I should jump in and start doing math. Remember, there's no calculators allowed on the quant section. For integrated reasoning, there's an on-screen calculator. But for quant, and I would say thank goodness there's no calculator, because it's not just about your math skills. Problems on the GMAT quant section are also about your critical thinking skills and your problem-solving ability. Here's a sample question. If A equals 105, and A cubed equals 21 times 25 times 45 times B, what is the value of B? Now, a lot of rookie test takers jump in and start doing some calculations on their paper. 105 cubed, so that's 105 times 105 times 105. You get some big ugly number, assuming you didn't even make a mistake doing it. And then 21 times 25 times 45, get some other big ugly number. Divide the first big ugly number by the second one. Hopefully not make a mistake, and now you've eaten up so much time. This is a wrong way to go about it. That's why step one of any the Kaplan method for problem solving for any question like this is analyze the question. It's important to understand the psychology of the test makers. They could have picked any numbers in the world. There's a reason these are the numbers they picked. And if you ever feel like the GMAT is asking you to multiply or divide big, ugly numbers, stop yourself. Chances are there's a shortcut, and one of the many great shortcuts for problems like this involves prime factorization. Each of these numbers, 105, 21, 25, 45, can be expressed as the product of some prime numbers. Now, of course, we'll put in the 105 for A, so 105 cubed is 21 times 25 times 45 times B. And all those numbers on the right we can express as some prime numbers multiplied together. 21 is 3 times 7, 25 is 5 times 5, and 45, well, that's 9 times 5, but 9 can be broken down further into 3 and 3. So 45 is 3 times 3 times 5. Okay, involves a little writing, but the math itself really isn't so bad right now. What about on the left side? We have 105 cubed. Well, let's just start with 105. You can just tell by looking at 105 that 5 goes into it, it ends in 5. Well, 5 times what? A little logic goes a long way. You don't have to jump in and start doing your long division. 5 times 20 would have gotten us up to 100. But this is 105, so we need one more 5. So that's 5 times 21, and 21 is 3 times 7. So 105 is 3 times 5 times 7. And of course it's cubed, so it's that cubed. Well, now this just becomes an exercise in what mathematicians call, this is a very technical term here, it becomes an exercise in what mathematicians call crossing stuff out. So notice here some stuff we can cross out. On the left side, we have 3 times 5 times 7 cubed, so we'd have 3 3's. Well, there's also 3 3's on the right, so that means all those 3's can get crossed out. Same deal with the 5's. On the left side, we have 5 cubed, so that's 3 5's, and we also have 3 5's on the right, so those 5's can be gotten rid of as well. So that leaves us on the left with 7 cubed, 7 times 7 times 7, and 1 7 on the right. So one of those 7's can get canceled out, leaving us with 2 7's on the left, 7 times 7, or 7 squared. Well, we know what 7 squared is, it's 49. Well, that beats the heck out of sitting there doing out 105 times 105 times 105 and getting some big ugly number and dividing that by whatever big ugly number 21 times 25 times 45 is. It's important, remember it's a time test. So if you had an unlimited amount of time, would it really matter which way you did this problem? No, but you don't have an unlimited amount of time. Our goal, if you're going to be one of the top scorers on the GMAT, is to get problems not only right, but get them done efficiently, as painlessly as possible, and not burn up a lot of time that might be useful on other problems down the road. It's important to remember, as we saw here, that any positive non-prime number, like 105 or 21, 25, or 45, can be expressed as some prime numbers multiplied together. Prime numbers that way, they're like the building blocks of non-prime numbers. And of course, prime numbers are things that can only be divisible by themselves and 1. Like we saw here, 3, 7, 5 are primes, the building blocks of non-prime numbers. Well, we're going to take a look at next some problems that, and this is where it's probably a good idea for you to grab some scratch paper and a writing implement of some kind, because some of the other problems we're going to look at, I'm going to give you a chance to actually try them out on your own, and then we can talk about them together. Well, here's the first one. This is a data sufficiency problem. We'll talk about kind of an introduction here to what data sufficiency is, and then I'll give you a minute to try this problem out before we actually discuss it. If ABC is not equal to 0, is A greater than 0? This is what we call a yes-no data sufficiency problem, because that question, is A greater than 0, can be answered with either a yes or a no. Now, with data sufficiency, these two statements that you're given, each one is true. Each one is a fact, and you must accept that. Now, I'm going to give you a chance to try this out. I'm going to pause my camera, and you can pause the video as well while you try it, and then afterwards you can unpause it for us to discuss the problem. Go ahead. All right, now that you've had a chance to try it out, let's talk about this problem. On test day, those 5 answer choices never change. That means that you don't need to actually spend a moment, not a second, not a millisecond, actually reading through each of these 5 answer choices on test day. They will be word for word exactly the same. So you should memorize them, not word for word, but memorize what each one represents. Now, on test day, there'll just be 5 bubbles, like you see there to the left of each answer. At Kaplan, we call the 5 answers 1, 2, T, E, N, and we'll talk about here in a second what each one of those represents. One of the nice things about data sufficiency is it's not about you solving. It's about you identifying, is there enough information so that the problem can be solved? Once we identify that this is a yes-no question, is A greater than 0? Here's where we set our standard for sufficiency. If from a statement we find out for sure that A is greater than 0, that it's positive, then the statement will be sufficient. If we find out for sure that A is not greater than 0, that it's negative, well, or 0, then it's still sufficient. As long as we find out for sure one way or the other, a definite yes or a definite no, either one is sufficient. But if from a given statement, maybe A could be positive, maybe A isn't, that's when it's insufficient. And it's where a little logic goes a long way. Let's take a look at statement number 1, which we look at by itself, and we must accept it as a fact, as with any data sufficiency problem. We have here a fraction that we're told is greater than 0. So that left side is positive. Well, that tells us there's a few possibilities for the numerator and denominator. Either 3A is positive and B is also positive, or 3A is negative and B is also negative. So that means there are 2 different possibilities here. Either A and B are both positive, or A and B are both negative. Well, from statement 1 by itself then, we don't know for sure if A is greater than 0. It could be if A and B were both positive, but it would not be if A and B were both negative. We didn't get from statement 1 by itself a sufficient answer to the question, is A greater than 0? That's where we say that statement number 1 is insufficient. Now, as soon as you're done evaluating statement number 1, you should start crossing out answer choices. When statement number 1 is insufficient, cross out 1 and E. Think of the 1 as standing for the first statement is sufficient, that's why it's a 1. Well, we just found out it wasn't. And the E stands for each statement is sufficient, or either statement is sufficient, which can't be the case here because statement 1 was not. 1 and E are a block. If you find out statement number 1 is insufficient, cross out 1 and E. If you find out statement number 1 is sufficient, you keep 1 and E and cross out everything else. Now we look at statement number 2 by itself. We have a fraction that is less than 0. So that left side has to be negative. But the denominator here, AC to the 4th power, well, that's got to be positive because anything raised to an even exponent will give you a positive result. So if that denominator is positive, then the numerator b has to be negative. That's what we find out from statement number 2, that numerator b is negative. But by itself still doesn't let us know whether a is positive or not. I mean, whatever a was, ac to the 4th, anything to an even power is going to yield a positive result in the denominator on the left. So statement 2 is insufficient by itself as well. It didn't answer the original question above of is a greater than 0. So there's one more answer we can cross out then, 2, because that's what we pick if statement number 2 were sufficient by itself. So now we have to combine the statements. A common rookie mistake in the beginning for beginning test takers is to combine those statements prematurely when the only time we need to do it is if each statement is insufficient by itself. Well, now when we combine the statements, we take the information that we found out from both of them. Statement 2 tells us B is negative, and in statement 1, we found out either A and B are both positive, which now can't be the case that we're taking them together. So then A and B are both negative, because the two statements are not always, they are not only always true, but they also never contradict each other. So if B is negative, it's that second scenario in statement 1 we're looking at, where A and B are both negative. So we find out, is A greater than 0? Well, taken together, statement 1 and statement 2, is A greater than 0? We find out definitely no, because B is negative and A and B have the same sign, so A is negative as well. So that means taken together, they are sufficient. So that's our third answer choice, T. Think of the T as standing for together, they are sufficient, but not individually. The N at the bottom, that stands for not even together, not even when taken together are they sufficient. Now, also a lot of beginning test takers fall into the trap of thinking, oh, well, it's a definite no. Doesn't that mean insufficient? No, it doesn't. It's like if somebody asked me, Gene, are you going to the party tonight? And I said, no, I am not going. Well, I have sufficiently answered the question. My answer was no, but I have sufficiently answered the question. Same deal here with data sufficiency. Is A greater than 0? If we get a definite yes or a definite no, in either case it's sufficient. Here we had to combine the statements for that. Well, let's take a look at another problem here. This is a sentence correction problem. Also, I'll give you a minute to try it out. I'll pause my camera and you can try it out and pause the video. And you can unpause it when you're ready for us to talk about the problem. Take a look. All right, let's see how you did. One of the nice things about sentence correction, and I guess it's true about the whole GMAT as well, this is a predictable test. It has to be because GMAT scores are good for 5 years. So business schools have to compare your score to somebody who took the test a year ago or 3 years ago. That means they have to bring up the same kinds of problems over and over again, same kinds of concepts, same kinds of right answers, trap answers. Well, in sentence correction, there are 6 error types that collectively represent 93% of problems, even when you get into the high difficulty ones. So that means if you keep your eyes peeled for those 6 big error types, and this problem illustrates one of them, it gets you a pretty high, pretty significant portion of points on test day, 93%. The average starting MBA salary of a person with a 700 on the GMAT is $5,000 higher than somebody with a 690. Well, there's a comparison being made here. The average blah, blah, blah is higher than blah, blah, blah. Well, comparisons, that's one of the big 6 errors. We got to make sure that we're comparing apples to apples, comparing like terms. The average starting MBA salary of a person is higher than somebody with a 690. Well, this is not a logically correct comparison. We can't compare the salary of one person to somebody else. That would be like comparing Bob's hair color to Jim. You can't compare Bob's hair color to Jim. You'd have to compare Bob's hair color to Jim's hair color. So we need to get rid of any answer choices that have the comparison of a salary of one person to another person. That's A and C. You'll notice, by the way, A is the same as the original sentence. So that will always be the case. If the original sentence was right, you pick A. Otherwise, you correct it with B, C, D, or E. But you don't just read all of A, all of B, all of C, etc., see what sounds good. We need to be more targeted than that if we're going to be high scorers on the GMAT by looking for those big error types. A says then somebody with a 690. C then for somebody scoring a 690. No, we need to have the comparison of the MBA salary of one person with a 700 to the salary of another person with a 690? Well, we have the not only comparison needs to be logically correct, needs to be grammatically correct too. The salary of a person with a 700 should be higher than a salary of somebody with a 690. Well, we have in answer choice E, instead of then the salary of somebody with a 690, puts in a pronoun, then that of somebody with a 690. That replaces the antecedent salary. Notice answer choice D, one thing that it has going for it, is the with a 690 that it ends with, but uses that incorrect pronoun and usage than it is for somebody with a 690. Comparisons show up a little more on the high difficulty sentence correction problems because they can be a little more subtle than some of the other types of errors in sentence correction. When you read that sentence, I'm sure you knew what it meant, but just knowing what it meant, that's not good enough to get right answers on sentence correction on the GMAT. The test makers are meticulous in how they craft their sentences. We have to be meticulous in how we pick them apart. So with answer choice E, now we're comparing the salary of a person with a 700 to the salary of somebody with a 690. This also is a relative of parallel structure, one of the other 6 common error types. So salary of a person and that of somebody. We have to stay consistent with the constructions and the comparison. Every little bit, especially when you get to those high scores, not only makes a difference for your GMAT score, but there's also a huge correlation with your GMAT score and your starting MBA salary. You'll notice that in this chart that you see here on the screen. Every extra bit helps. For example, see somebody here with a 640, starting salary is about 85,000, certainly nothing to sneeze at, but once you get up to like a 700, starting salary is closer to 115. It's a pretty significant difference. So the time invested in studying for the GMAT is certainly well worth it. Let's take a look at another problem. I'll bet you thought back in high school you'd never have to look at these darn train problems ever again. Remember those 2 trains barreling towards each other? Well, this problem deals with something exactly like that. Train A, and you thought you'd never have to deal with it on the ever again after high school. Surprise! Sometimes you have to on the GMAT. Train A left Centerville Station heading toward Dale City Station at 3 p.m. Train B left Dale City Station heading toward Centerville Station at 3:20 p.m. on the same day. The trains rode on straight tracks that were parallel to each other. If Train A traveled at a constant speed of 30 miles per hour, Train B traveled at a constant speed of 10 miles per hour. The distance between the 2 stations is 90 miles. When did the trains pass each other? Now, again, I'll give you a chance to work on the problem. I'll pause my camera and you can pause the video, and then when you're ready to review, we'll see how you did. Check it out. All right, let's see how you did. Here we have 2 trains barreling towards each other. It would be a little bit easier. Maybe it wouldn't have been a 700 problem if they started at the same time. They started at different times. Now, if I were your high school math teacher, I would want you to set up a bunch of ugly-looking equations called the distance for A, the distance you see here on the left, since speed equals distance over time, could manipulate that formula of distance equals speed times time for train A. For train B, use some substitution, know that there's a difference of 1/3 of an hour between them. Eventually, we'd get to the right answer that way if you didn't make a mistake somewhere. Maybe though setting up all these ugly equations wouldn't be the most efficient way to go. I mean, look, we care about you maximizing your score on the GMAT. If you were able to say to me, oh, Gene, I could rub a lucky rabbit's foot and get the right answer consistently, I would say, good, do that. We're interested in getting you the highest score possible by any reliable means. Until somebody comes up with a rabbit's foot like that, or some other kind of talisman, we want to use a little more logic and then supplement it with a little bit of math. So let's understand what's going on here. These trains are barreling towards each other. They're 90 miles apart. When two trains, or people, or dogs, or cats, are working together towards some common goal, we're allowed to add their rates. Maybe I should say not just we're allowed to, but that's exactly what we should do. Train A is going 30 miles an hour, train B is going 10 miles an hour. So together they're moving towards each other at 40 miles an hour. If you think about it for a moment, what happens every hour is train A moves 30 miles more to the right, and train B moves 10 miles more to the left. So every hour they get 40 miles closer. But there's a time period before they really start working together. There was that 20-minute head start that train A had. So we got to figure out what happens during that 20-minute head start. Well, train A had a 20-minute head start. 20 minutes, that's 1/3 of an hour. If train A was going for a full hour, it would be 30 miles. But with 1/3 of an hour, that means it's 1/3 of the distance. Instead of 30 miles, that means it's 10 miles that train A goes in that 20 minutes. It's 1/3 of an hour, so it's 1/3 of 30 miles in that hour, 10 miles. So now it's 320. And now that it's 320, now it's not 80 miles between them anymore. Now that it's 320, now all of a sudden, it's not 90 miles that's between them anymore. Now at 320, now it becomes 80 miles that's between them. But starting at 320, they are starting to barrel towards each other. So now we can use the combined rates for the two trains. Speed equals distance over time. Well, their combined speed is 40 miles an hour. And now the combined distance they have to cover, starting at 320, is 80 miles. Speed equals distance over time. So 40 miles an hour equals 80 over what? Well, it's 80 over 2. That equals 40. So it's 2 hours. But 2 hours from when? 2 hours from when they started both actively moving towards each other. So that's 2 hours from 320 gets you to 520. This way, we didn't have a bunch of variables like distance of A and distance of B with substitution. Remember, in school, it's nice because if you do 10 algebraic steps, if you make a mistake in one of them, your teacher can look at it and say, well, you're kind of doing the right thing. Let's give partial credit. No such thing as partial credit on the GMAT. So if you have 10 algebra steps, if you make a mistake in one of them, you're sunk. Nobody can look and say, well, you were kind of doing the right thing. So a little bit of logic goes a long way. Well, in geometry problems, here's one, question number 4. The formulas are very important to know, and man, are there a lot of rules in geometry, especially for triangles. One of the first things that we have to ascertain is what rules are involved, what rules are in play. Well, again, with this problem, I'm going to give you a chance to try it out. I'm going to pause my camera. You can pause the video, and then when you're ready to review it, unpause the video, and we'll talk about this problem. Good luck. All right, let's review this one. So we have a triangle, and we're being asked about the area of it. The formula for area of a triangle is 1/2 base times height. And with any triangle, base and height must be perpendicular to each other. If they're not perpendicular, then you don't have base and height, and then you'd get the wrong answer for area. In a right triangle, if this was a right triangle, that would be beautiful because we'd have 2 legs that are perpendicular. We'd call one of them the base and one of them the height. But unfortunately, this is not a right triangle. So how do we find the height? Well, you can call the base whatever side you want to be the base. But then you'd have to draw your own height going from the opposite corner. Sometimes with a problem like this, you may feel the urge to make this bottom side the base. Makes sense if that's your first instinct, and it's nice they do give you the length of it. But then if you were to draw your own height, you'd start at the opposite corner, drawing a line straight down, and how are we going to find that height? There's no way we can find that. So one of the things you see in some of the higher difficulty problems, 700 or above, is problems that force you to draw a line somewhere. Everybody always says, right, you got to know where to draw the line, so that you can separate this shape into figures that you can do something else with. Because we can call this long side the base, and then draw our own height going from the opposite corner down to that base. Now, the reason we should get excited about this as high-scoring GMAT students, well, as excited as we can get, it's a GMAT problem, let's control ourselves. The reason we should get excited about this is by drawing that perpendicular line. We've separated this uglier looking triangle. I mean, there's no rules for a 30, a 105 degree triangle. We've separated into two triangles that do have some better rules to work with. Notice this triangle here on the bottom now has a 90-degree angle. And for the big triangle, remember all angles in a triangle have to add up to 180 degrees. So for that big triangle, we have a 30-degree angle, a 105-degree angle. That gets you to 135. So that remaining angle has to be 45. Well, that's nice then for that triangle on the bottom, a 90 and 45, then its remaining angle has to be 45. So that 105 degrees splits up into 45 and 60. Well, now we've broken this triangle up into a 45, 45, 90 and a 30, 60, 90. And the thing with a lot of triangle problems, of course, you've got to know the rules, but also you see some of these special ones, 30, 60, 90, and 45, 45, 90, they come up in some of the harder problems. Now, what do we need to know about those different kinds of triangles? In a 45, 45, 90 triangle, you're always going to have sides in proportions of x, x, and x root 2. In any triangle, sides are associated with the angles across from them. So notice here, across from a 45-degree angle is x. Across from the other 45-degree angle will also be x. After all, equal angles have equal sides across from them. And across from the 90 will be x root 2. Well, whatever x is, could be 5, 5, 5 root 2. In a 30, 60, 90, across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. Well, in that 45, 45, 90 triangle, across from the 90 is 2 root 2. So if x root 2 is 2 root 2, then x is 2. That means those legs of that right triangle are 2 and 2. And that helps us with the 30, 60, 90 now. Because across from the 30 is 2, so that's x. So across from the 60 will be x root 3, or in this case, that's 2 root 3. That's across from that 60. Well, now this is exciting because we now know the base, that long side, let me highlight it here in blue, and we also know the height that's perpendicular to it. So now we can use that area formula, 1/2 base times height. Now we can use it. Well, 1/2 base times height, that's 1/2 times 2 root 3 plus 2, that's the length of that long base, times the height, which is 2. Well, when we're multiplying 1/2 base times height, the order in which you do it doesn't matter. So I'd start with the easier ones. 1/2 times 2 is just 1, so they cancel out. We're just left with 2 plus 2 root 3, or 2 root 3 plus 2, they're the same thing, which is in the answer choices. Not super pretty to look at, but that's the length. The root 3 doesn't break down anymore. This is the kind of problem where, and you see a lot more of these when you get into the high difficulty questions, around the 700 ballpark. If you know those rules for a 45, 45, 90 and a 30, 60, 90, a problem like this becomes much more manageable. If you don't know those rules, I don't know what you do. You hope for the best, I guess, eeny, meeny, miny, mo, I suppose. That's why if you want to be a top scorer, those rules have to be really solid. I always tell all my students that if you want to be a top scorer, it should get to the point where I could call you up at 3 o'clock in the morning. I mean, I wouldn't do it, it's creepy. But if I did, call you at 3 o'clock in the morning and say, what are the proportions of a 30, 60, 90 triangle? And you say, oh, it's x, x root 3, 2x. Now stop calling me at 3 in the morning, you weirdo. That's how solid that needs to get. So that on test day, you don't have to sit there thinking about, oh, what do I do next? Step 1, we analyze the question. Once we state the task of finding the area, then we can approach strategically with separating into these triangles, the two special ones that we do have rules for. Well, let's turn our attention next then let's turn our attention to a critical reasoning problem. This one we're going to look at together. We have the problem here on one slide, and we're going to have the answer choices on another slide. But it's because it's a very specific way we should talk about doing this problem. With critical reasoning, we Kaplanites always read the question first. Which of the following, if true, best supports the PR rep's argument? We read the question first because that way we know what to look for in the argument above, or sometimes we call it the stimulus. A common rookie mistake is to immediately, once you read the argument and the question, immediately go to the answer choices. But it's important to take a moment and break down the argument and make a prediction for what it is that you're looking for. The more proactive you can be in doing that, the less likely you are to get swayed by a tempting but wrong answer. When we want to support an argument, in real life, there's a lot of ways to strengthen an argument. On the GMAT, it's a much more specific way to do it. A local biopharma startup is trying to get a foothold in a competitive field of research. The company's PR rep stated, "In order to attract and retain the best science managers, we offer salaries and bonuses at double the industry standard. Our engineers work with the best science managers in the industry. Clearly, engineers at this startup will produce the best results." Now, when you paraphrase the argument to yourself, you should identify the conclusion first. Oftentimes, there's conclusion words or phrases, things like thus or therefore. If not, see which sentence, or sometimes part of a sentence, best represents the author's viewpoint or the author's position that gets supported by everything else. Here, it's that last sentence. Clearly, engineers at this startup will produce the best results. And that's the conclusion based on what evidence? Oh, because they're paying their managers so much money, the salaries and bonuses, at double the industry standard. Well, when we see certain patterns come up on the GMAT, and as I mentioned before, it's a predictable test, then we can be very targeted with our predictions. When a conclusion is a plan, proposal, or a prediction, we can strengthen it by ensuring circumstances that favor it. Here, the author of this argument concludes that these engineers will produce the best results. That's a prediction. Future tense, of course, will produce the best results. Well, how do we know that? Well, because they work for managers that get paid so much money. Now, if you were trying to weaken an argument like this, you might say, well, how do we know getting paid so much money would actually produce such good results for those managers? And maybe that would be our prediction if we were trying to weaken. But we're trying to strengthen. So what we want to do is find an answer choice that confirms those circumstances that favor that result. In other words, confirm those circumstances where getting paid all that money is going to make those managers help the engineers get the best results. Or another way to say it is to remove some kind of other factor from being involved that would prevent these results from coming true. Now let's look at the answer choices. Now, I'll give you a moment to check them out. I'm going to pause my camera, and then we'll talk about it afterwards. You can pause the video as well as you decide which answer to pick. All right, let's talk about the right answer here. In that argument that we were just looking at a moment ago, the author concluded that engineers are going to get the best results because they work for these managers that are paid so much money, that having all that money is going to help these engineers produce the best results. What will help the managers get the engineers to produce the best results. So if we can get rid of other factors other than the money getting the best results, that would confirm that, yes, this prediction will hold. And we have that with answer choice D. Making a difference in the field of medicine is not the primary motivation of the best biopharma managers. Answer choice D removed some other motivation, making it more likely that getting paid so much is going to help those managers make the engineers get some good results. There's also something that we like to use in high difficulty problems at Kaplan to help confirm our answer, something called the denial test. Here, with answer choice D, okay, if we pick it, if it's the right answer and it strengthens the argument, denying it should somehow go against what the argument says. If we denied answer choice D and said that making a difference in the field of medicine is the primary motivation in the best biopharma managers, well, if making a difference in the field was their primary motivation, then the money wouldn't be the most important thing in attracting the top talent. And of course, the author of that argument used the high amounts of money paid to be the evidence for why good results were going to come from that biopharma startup. Is the denial test something you should use on every single problem? No. I don't think it would be an efficient use of your time on every single problem. But it's good to use if you're ever stuck between a couple answer choices and on high difficulty problems to confirm that the answer you picked was right. All right, one more. Question number 6. A lot of times students feel like, oh, I've seen so many of these combinations, permutations, statistics types problems. Is that a good sign? And the answer is, yeah, absolutely. One of the important things, and we'll talk about this after the problem, is when you're studying for the GMAT to target the areas that are going to get you the most points. When I've had students that are scoring 500 or 550, I tell them not to care so much about things like combinations, permutations, and arrangements. But for top scores, it's something you have to care about because you start seeing them a lot more when you get into those high difficulty problems. All right, well, let me shut up. I'll give you a chance to try this problem out. I'm going to pause my camera, and then you can pause the video and unpause it when you're ready for us to talk about it. Check it out. All right, let's discuss this problem. There must be a lot of different arrangements for these digits. How many different positive integers having 6 digits are there, where exactly one of the digits is a 3, 2 4s, a 5, and then each of the other digits is a 7 or 8, and a 7 or 8. Well, we want to start placing these one at a time. Well, okay, we got a 3, 2 4s, a 5, and then a 7 or 8, and a 7 or 8 into those 6 slots. Well, let's start with the ones that are distinct. Let's start with the 3 and the 5, since they are distinct and we only have one 3 and we have one 5. We need to somehow place in those 6 spots a 3 and a 5. Now, it might take a while to actually list out all the different ways it can go. To place go first and third, first and second, first and third, first and fourth, first and fifth, and then each of those could flip-flop. I mean, an animation could happen a lot of different ways. So what we can do there is use the permutation formula. The permutation formula, and you see it on the screen there, goes like this, and I'll put it on the upper left. N factorial over n minus k factorial. The n is how many we're picking from. Well, we're picking from 6 slots. And the k is how many we actually want to use, how many slots we want to fill, which is 2. So out of 6 slots, we're picking 2 to put the 3 and the 5. So on top we have 6 factorial, and on the bottom 6 minus 2 factorial, or 4 factorial. Now let me acquaint you with, or reacquaint you with, if you've dealt with it before, that factorial, the exclamation point. I had a math teacher who used to call these the excited numbers. Get it? The 6. No, it's not the GMAT being excited about 6. 6 factorial just means 6 times every positive integer smaller than 6. 6 times 5 times 4 times 3 times 2 times 1. And on the bottom 4 factorial is 4 times 3 times 2 times 1. We don't need to multiply all that out on top and on the bottom. Some stuff cancels out. In fact, that string of 4, 3, 2, 1 is on the top and it's also on the bottom. So we're just left with 6 times 5, which is 30. Now, that means there's 30 different ways that you could place a 3 and a 5 in those 6 slots. And we use the permutation formula when order matters. For example, putting a 5 in the 5th slot and 3 in the 6th isn't the same thing as a 3 in the 5th slot and a 5 in the 6th. We use that permutation formula when order matters. Well, now we have 2 of those slots filled and 4 slots left, in which we're going to have to place a couple of 4s. Well, those couple of 4s we can put in first and second, first and third, first and fourth, way too many to list out. But here we're going to use the combination formula. Here we had permutation. Make sure I'll label that up top. That was the permutation formula. The combination formula looks very similar. It's just got one extra little piece. Still n factorial on top. On the bottom, k factorial times n minus k factorial. So it looks very similar, except it's got that extra k factorial on the bottom. Again, n is how many slots we're picking from, in this case 4, and the k is how many we're actually filling. In this case 2. We have to place those 2 4s into those 4 slots. Now, how come here we're using a different formula? How come here we're using the combination formula? Well, combination formula is what we use when order doesn't matter. The reason with the 4s order doesn't matter is because if you have 2 4s, first and second, versus second and first, it's the same thing because they're identical. The 4s are identical, whereas putting 3 first and 5 second is different than putting 5 first and 3 second. There, the order actually mattered. So here we use that combination formula, 4 factorial, 4, 3, 2, 1. On the bottom, 2 factorial times 2 factorial, which is 2 times 1 times 2 times 1. And again, some stuff is going to cancel out. So we have 2 times 1 and 2 times 1. So we're left with 12 over 2, or 6. So now we're left with 2 more slots with a 7 and 8. Well, each one is either a 7 or 8, 8 or 7. So it can go 7, 8, 8, 7, 7, 7, 8, 8. When the numbers are small enough, you don't need a formula. You can just list them out. So that's 4 more combinations, or 4 more outcomes for those 7s and 8s. Well, when we decide what we're going to do with these, 30 different ways to place a 3 and a 5 in the 6 slots, 6 ways to place 2 4s in the 4 slots remaining, and then once we do that, we have 4 ways to fill the other 2 slots with a couple of 7s, couple of 8s, or a 7 and an 8. When you decide what to do with those, the 30, the 6, and the 4, talk to yourself and see if you use the word and or. With and problems, we multiply. With or problems, we add. And is much more common, because think about what we want to do with all those numbers that we originally started with. We wanted to place a 3 and a 5, and a couple of 4s, and put in a 7 and 8 in there somewhere. Ooh, that's an and problem. So we have to multiply those. 30 times 6 times 4, that's 720. 720 different arrangements of all those different numbers. Would have taken forever to actually list those out. That's why those formulas are important. However, when the numbers are kind of small, like we had with the 7s and 8s, there you can just list them out. For example, if we have 3 people running for office and we have to elect one of them, you don't need a formula to tell you there's 3 different outcomes. Either person 1 wins, or person 2 wins, or person 3 wins. Now, you've seen today some pretty tough problems, 700 level problems, of the variety that you would see in that ballpark on test day. The best practices to score above a 700, well, there's a few things that I would say I've seen top scorers have in common. They certainly do their homework. They have that going for them. There's also, I would say, kind of a almost an interest, a passion for matching wits with the test makers. You want to make sure that you do focus on those high value areas. I'll look at that a little bit more in a moment, and increase your efficiency so that you can get through 37 problems in math, or 41 problems in verbal, and you want to improve your execution as well. If there was no time limit on this test, things like efficiency or execution, or efficiency of execution, wouldn't matter as much. But when that clock is ticking, you want to make sure that you're getting problems not only right, but kind of a little damage control too. Get them right in the quickest, most efficient way possible, so you don't fall victim to some of those silly little mistakes. Now, how to identify those high value areas. Now, overall, those top 5 quantitative areas that get tested: data sufficiency, number properties, proportions, geometry, and for top scorers, especially combinations and permutations. But that's kind of how it is for everybody that wants to be a top scorer. For your personal top 5 areas, those need to get addressed even more specifically. For example, number properties, that covers a lot of ground. Odds and evens, positives and negatives, factors and multiples, things like that. Proportions covers a lot of ground too. Ratios, for example, as well as mixture problems and things like that. So this is why we'll talk in a minute about why something like SMART reports is so handy to use. You want to build in those high value areas into your roadmap. The higher you're scoring, the more it changes what kinds of problems you'll see more of. Like if you're going from a 610 and you want to get to a 700, a solid foundation of algebra and geometry is absolutely important. And then incorporate that with some test methods, like a little logic like we did earlier with that problem with the 105 cubed. And then practice it over and over and over, beat it to death till you get really comfortable and natural with it. Now, once you start going a little bit higher, then fractions and ratios start coming up a little more often, but still needs to be built on with test methods and test-taking practice. But all the way up to a 760, now you're going to start seeing a lot of statistics and permutations, arrangements problems coming up. But notice there, we have test methods at the bottom of the pile. Now that doesn't mean that they are the least important. In fact, just the opposite. It means those test methods become your foundation by which to analyze problems strategically and think about, do I even need to use a formula? Do I need to use any calculations? The test makers, and I do joke around sometimes with my students saying, oh, the makers of the GMAT, they're sneaky people. But the fact is, they really do give you good opportunities to get rewarded by spotting some of the patterns that show up on this test. And it's certainly important that you increase efficiency. I think I mentioned at the beginning today that you could take a perfectly good score, the great content knowledge, but if you don't have good efficiency and you end up running out of time, say around question 32, and then leave the other questions unanswered, you run your score into the ground. You can take a perfectly good score, and somebody scoring what, around a 700? Make it plummet with those last 5 questions if you leave them unanswered. Because on the GMAT, a blank answer is not only wrong, it's worse than that. A blank answer is a wrong answer, and then there's a penalty tacked on top of it. It'd be pretty, I wouldn't say impossible, but pretty close to it to get one of those top scores by leaving a bunch of questions blank at the end like that. Can totally make your score plummet by doing it. That's the cost, the score cost of inefficiency. Differs a little bit from test to test how much the penalty is, but it's usually in the ballpark of around 3 or 4 percentile points. That's pretty significant. That's something that can keep an otherwise good scorer out of business school. So you want to reduce the uncertainty by improving your execution. There are a few sources of uncertainty. Statistical randomness with a computer adaptive test, there's a little bit of luck of the draw involved. But if you have uncertainty in your execution, well, that's a lot more problematic because that's something you can do something about. Those 3 things collectively can impact your score 114 points on average. It's, of course, an average from 200 to 800. But what you can do something about is the third one, improving your execution. By practicing methods over and over again, seeing the same kinds of problems come up over and over too, helps you do that. That starts to make that bubble on the right shrink a lot. Starts to make that bubble on the right shrink significantly. There's a little bit of luck of the draw of what you get on the test, but that's something that you can do something about is improving your execution. Now, it is important to do drills to do that. There is, though, and we see this not only on the GMAT, we see this, I think, in most areas of life. Here you see a football player. There's a little difference between drills versus realistic practice. Drills look more like that. The real thing looks more like this. So you want to make sure that, yeah, you do drills, but you also use some realistic practice, practicing by content type, and doing some full-length tests. Getting used to the dynamic of a computer adaptive test is vital for top scorers. Make realistic practice actually realistic. Make sure you're taking adaptive tests. If you do 37 math problems that are on paper, that doesn't really mimic the dynamic of a computer adaptive test. Same thing, by the way, with scratch work. When you see a geometry problem that came up on the screen today, you can't write on the screen. I guess you could try to do that on test day. They'll probably kick you out. They don't really like that when you take your markers to their expensive monitors. You want to make your scratch work mimic what it'll be like on test day. They give you this noteboard. Kaplan gives you noteboards like this as well with a marker, the same kind that you use on test day, so you can get used to using it and try and make conditions as similar as possible to the test. Now, if you want to get into that ballpark of 700 or above, the average hours of study time we find is around 119 hours. Figure a couple hours a day for 2 to 3 months. That's the benchmark of successful preparation. Now, of course, the quality of time you spend is important too. It's not like, oh, if I hit 119 hours, then magically my score is going to be a 700 or above. No, the quality of time you spend is important as well. Your job is to execute the methods over and over again. Learn from your mistakes. Everybody gets stuff wrong when they're practicing, including me and every Kaplan teacher. We weren't born Kaplan GMAT experts. But it's important to learn from your mistakes, make them happily, so that the next time you see a problem like that that you made a mistake on, you have reason to believe that it will get better. Now, in order to prep effectively, you certainly need a good attitude. As I mentioned before, top students enjoy matching wits with the test makers. And it's important to have the time, a few months, a couple hours a day, and some good practice materials as well. Kaplan has the largest question library, including over 6,000 practice items, kind of hard to run out, and 9 proprietary CATs, that's computer adaptive tests. And each one of them has the same format, same dynamic of it gets harder as you do better and it gets easier as you do worse. On top of those 9, you also get 2 more from MBA.com when you register for the GMAT. Expert Teacher helps as well. Here's a smattering of some of our top teachers. Oh, wait a second. I thought I was about to bring up the slide of some of our expert teachers, but then I look at this picture at the lower right. I realize these are just the best looking people at Kaplan. No, I'm joking, of course. These are just a smattering of some of our top teachers. And the thing with Kaplan teachers too, not only obviously did we all qualify, we all scored very high on the GMAT to teach, but Kaplan has a pretty rigorous training program too. So out of only 1 out of every 10 teachers that even score qualifies gets through the training program to teach. Because sometimes students, when they're talking about their college professors, often have this complaint that they'll never have about Kaplan teachers. Maybe with your college professor, you said, oh, smart man or smart lady, but couldn't teach because he or she couldn't relate to students. You'll never have that kind of problem with a Kaplan teacher because, well, not only the rigorous training I talked about, but we were all in your shoes not that long ago, so we know what kind of obstacles students encounter, so we know how to address those things. Now, on top of that, I mentioned earlier that you want to simulate test day as much as possible. Well, a Kaplan exclusive is what we call the official test day experience. Out of those 9 CATs, you can take them at home, at the office, anywhere you have an internet connection, but we also offer you the opportunity to take a full-length real practice test at an actual Pearson Center where you'll be taking the actual GMAT itself, where the score doesn't count, but you get to go through it. It's like a dress rehearsal for the real GMAT. They fingerprint you, check your ID. There's a camera 5 feet from your head. Students tell us all the time, even from just a psychological perspective, it made them feel a lot less nervous, a lot more calm about the real test. And preparation that's tailored to your needs helps you get a lot more bang out of your study time. We all have lives outside of studying for the GMAT. So you want to focus on, we mentioned earlier, What are the areas that you need to work on for where you're scoring? This is where Smart Reports, I think, is one of the coolest features of Kaplan's program. Smart Reports is like a built-in coach that answers the questions, how am I doing? And what do I do next? Every time you do an assignment, Smart Reports analyzes it for your strengths, weaknesses, areas of opportunity, which is not the same thing as a weakness. That takes into account how likely something is to even appear on the GMAT. And it creates customized assignments for you, because not everybody has the same strengths and the same weaknesses. I think that's one of the coolest features as well. Now, the way our course is structured at Kaplan, now that we're into the part talking that last item on the agenda, Kaplan GMAT prep options, it's 3 quant fixed sessions and 3 verbal fixed sessions that you can do online or in class, but those should be done first. And they build the foundation that you need to then build GMAT success off of. The 3 quant lessons are each 3 hours. The 3 verbal lessons are each 2.5 hours. After you complete those, we have a number of flex class sessions. And we call them flex for a couple of reasons. One, because, well, the scheduling is flexible because they're not grouped together like the fixed ones. You can do these 5 in any order. The other reason is because these other 5 flex sessions give you a chance to flex your GMAT muscles that you built in the fixed sessions. But the flex sessions are not any less important than the fixed sessions are. Geometry, statistics, and integrated reasoning for quant, and verbal mastery and analytical writing for the for verbal. And actually, there's 2 more as well that have recently been added: Quant Mastery A and Quant Mastery B. Each one is an hour and a half. Targets the hardest problems. Those are the 2 additional ones that we recommend for top scorers: Quant Mastery A and Quant Mastery B. So that's a total of 6 and 5. And then 2 more, the Quant A and Quant B, a total of 13 lessons. Now, Kaplan offers our program in 4 different iterations: on demand, classroom anywhere, classroom on site, and one-on-one tutoring. Classroom anywhere is our most popular option. Now, our most popular option of GMAT Advantage offers targeted and focused prep for students that need to study for the GMAT, but they need to balance that with their busy lifestyles. And we'll give you some promo codes here at the end in a minute as well. On-site, that's an in-person, formal, I shouldn't say formal, I guess traditional classroom. You're in a desk, teacher's in the front of the room. You can do Classroom Anywhere, which is an online classroom. Looks a little bit like this, well, except it's live, not a recording. And you have a teacher that's in front of you and some TAs as well. At Kaplan, by the way, TAs are also teachers. It's not like in college where they're secondary. And then on demand are recorded lessons. Recordings are wonderful. They're very convenient. You can do them at 2 o'clock in the morning if you want. But the on-site and Classroom Anywhere, part of the reason those are a lot more popular is because with on-site and Classroom Anywhere, there's a live teacher there and TAs. So if you have questions, there's a human being there to answer them. And your teachers are not just your teachers while you're in class. They give you their contact info so that if you have questions in between classes, you can ask them as well. Of course, one-on-one tutoring has the added benefit of convenience. You and your tutor can meet where you want, when you want. You can do it in person or on or online, and you and your tutor can work on the areas that the 2 of you decide you need fine-tuning. It includes a complete course enrollment as well. And Math Refresher, if you feel so rusty on math, if you haven't seen a lot of this stuff in years and years, maybe even back then it wasn't as solid, Math Refresher might be good to do for you. You can do it by itself or tack it on to a comprehensive course. And if you're going to be a top scorer, you need the confidence to prep effectively in addition to a good teacher and good practice materials and a good attitude. I love this statistic. More people get into business school with a Kaplan course than with any other major course. That means you'd be in very good hands. And we're pretty confident that the stuff works because Kaplan has the most comprehensive guarantee in the industry. You'll score higher on the GMAT or get your money back. And if you take the course and at the end you feel like, I'm still not ready to take it, do it all again for free if you want. We stand behind our course. We've been preparing people longer and better for the GMAT than any other test prep company that's out there. So look, you have to do your part too. You know, you come to class, yeah, that's good, but you got to come to class, pay attention, do your homework, make sure when you do your homework, you learn from your mistakes. You come to class, you do your part, we'll do our part. You'll be a very happy GMATer come test day. And the last slide that I'm going to put up are some promo codes. If you'd like to apply them, Event 50 for on-demand or classroom anywhere, and Event 100 for on-site and one-on-one. And in addition, of course, I guess to the monetary savings there, it also kind of saves you the aggravation of prepping the wrong way. The idea is you want to study for the GMAT, as we saw at the beginning today, over a fairly short period of time, a couple of months. It's an intense period of time, yes, a few hours a day, but over a fairly short period of time, and then you strike while the iron is hot. You go and rock this test, and then hopefully never have to look at any of this stuff ever again. Well, thank you for watching today's presentation. Hope you learned a little bit about the GMAT, about some of the high difficulty problems, and make sure you take this test seriously. Give it the attention it deserves. It certainly deserves it. You saw that chart earlier, how even little increases in GMAT score can make a pretty big difference in where you get accepted and starting salary after business school. So make sure you take it seriously, and good luck.